Dear all, Assalamu alaikum. Hopefully you are all well. So today I want to talk to you about the cramp scalation model and the Falcon N model. This is my main task for today. But parallel to this, I would like to talk a little bit about the all of the above reactions, all of the above given reactions. I mean the type of the stereoselectivity. I would like to talk about the regioselectivity, regiospecificity. I would also like to talk about the chemoselectivity and chemospecificity, dash stereoselectivity. We have already talked about the enantioselectivity, right? So before starting this crime calculation and the Falcon N model, I would like to have a little bit discussion about. I want to talk a little bit about all these reactions one by one so that you may have good idea about what these reactions are used for and what are their critical roles a role in the you know in the crime collation or the Falcon N model. First of all, let's see that what this T2 selectivity is all about. We have, I think, thoroughly discussed about this stereoselectivity during our last lectures, where we came to know that the stereochemistry in the substrate is responsible for directing the for deciding the future of the product. I mean, which type of the product you will have predominantly. This will be decided by the stereochemistry in the substrate or in the product. So if that stereochemistry is feasible at one position, if one of the site is blocked or hindered somehow, so there will be, for the coming nucleophile, there will be one feasible site for attack. That's why you will have predominantly one of the reactant, right? So, and the other reactant will be in a minor quantity. So if the major the one of the isomer in quantity and the lesser the other in quantity means that there is a high level of selectivity. If stereochemistry is involved in that selectivity, we say that that is stereoselective, right? So now your question would be that where the stereochemistry comes into actions if we are talking about this sort of the reaction. You can see that uh, cyclohexane usually exists in the chair conformation, right? Normally. Uh, but since it has a double bond, now this is cyclohexene, so it will be distorting a little bit from the chair conformation, but still there will be a chair conformation for this, right? So in chair conformation, you see that if there is an attack of the bromine group, of course the two bromine will come into and will join this ring, right? At 1 2 positions, yeah. So now the question is that what would be the preferable stereochemistry for that? So the possibility is that we will have both of these product, but this product they're saying that it's not farming because of the anti-additions, yeah. One of the because there is a cyclopropane ring formation, cyclobromonium ion formation, and after having that there is only a possible attack will be that the anti-addition, right, and we will have this kind of product. Similar, you see many more such examples where the stereochemistry decide preferential attack at one side and we say that the reaction is stereo-selective. But if this is not happening and only you are the at at one time only one product is possible, then we say the reaction is stereo-specific. We have so many of such reactions. I don't want to go into that detail because these are the quite common things which you have read about during your lower classes. Our target is to my today's aim uh, by discussing this sort of the thing is to remind you to give you a brief overview about those all those reactions. Now, what about the reduced selectivity? Again, there are two possible terminologies: reduced selectivity and reduced specificity. RegioSelectivity is coming from the, this sort of the term. This is more like deriving from the region, regio. So, because there are more than one site in the, if we have a substrate where more than one sites for the reactions are available, but the reaction taking place and preferentially giving one of these constituent isomer over the other predominantly. If one of the structural isomer is predominantly produced over the other, we say that the reaction is regioselective because there are more than one site available in the substrate, but preferentially reaction is feasible at only one site uh, under the given condition of the reagents. Why I'm saying this, it will be clarified in the next slides. Because see, if there is an attack of the nucleophile at this carbonyl group, that will be called the 1,2 addition. But if there's a nucleophilic attack over here, right, on this carbon, and then this will move here, and then this will be shifting over here, and another addition taking place here, then we will be saying that that will be 1,4 addition. That is called the Michael addition. 1,4 addition is called the Michael addition, and 1,2 addition is the is because of the, it depends upon the reagents. If we have harder nucleophile, it will attack on the, it will bring about the 1,2 addition. If we have the soft nucleophile, that will attack over here, and I mean bring about the 1,4 addition. So hard nucleophile, soft nucleophile, other things like the stereochemistry sometime may involve, sometime sometime the situations are as such where the preferential attack is only possible at one site. Under all those conditions, we would say that the reaction is regiospecific. Why? Because predominantly one of the constitutional isomer is produced over the other. This sort of the reaction is called, this kind of the reaction is called the uh, uh, Reju selective reaction. But you can imagine that sometime it's possible that you hinder one of the side completely and exclusively there is possibility of only one product at only one site on the substrate. Then under that condition we can say that the reaction is regio specific. So I think you have a good idea now what the regio select and what regio specific reactions are. There are so many other examples, and then the following slides will tell you that what will be the conditions that will give you the 1,2 addition, that what will be the condition that will give you 1,4 addition, that is the Michael addition. Depends upon the softness and hardness of the coming nucleophile, depends upon the reagent, depends upon such certain solvents. There is no single reason why the 1,4 substitution or 1,2 substitution is taking place, because a number of reasons will be there, and this and then you can decide that which but preferentially only one would taking place over the other. So under that condition we say that that is regio selective, otherwise regio specific. I'm not going into that detail. You can read these all these slides one by one. uh, as I said, that reactivities of the reagent that can also decide. Sometimes, if you are dealing with the hard nucleophiles such as organolithium, that definitely bring about the 1,2 addition. But if you are talking about the other, soft nucleophile, that's then there is possibility of the 1,4 addition. So you can read about all these slides one by one. That will tell you, that will give you the better idea about these reactions. Markovnikov, anti-Markovnikov is the best explanation and examples for a regioselective reaction. So you can read about all these things. These are very basic things. That's why I don't want to take much of my time on discussing these trivial things. Sizef and Hoffman rule, etc., etc. These are all the examples of the regioselectivity or regiospecificity. Now, what about the chemoselectivity? See, let me explain in the next video, right?